In the previous video, we defined like terms as terms that have the same variables. However, sometimes terms that look the same are not like terms, and sometimes terms that don't look the same are in fact like terms. This is part 2 of combining like terms. Welcome back to Dino 101. Take a look at these 3 terms. Are these like terms? At first glance, it may be tempting to think that they aren't. They don't even look alike. But in fact, all 3 of these are like terms. Each of these terms has one x, one y, and one z. Why does this mean they are like terms? Well, what do these notations actually mean? When variables are written side by side, that means they are being multiplied together. So here is another way we could have written these. Now, let's substitute in values for the variables x, y, and z. Let's let x equal 2, y equal 3, and z equal 8. No matter which order we use, we see that the answer is always 48. Rearranging the order of multiplication doesn't affect the term. This is the associative law in action. If you don't know the 4 major math laws, I encourage you to check out this video. The trick to finding like terms is to focus only on your variables. In this example, if we drop the coefficients and signs, we find that we have yxk, kyx, and xyk. And these are all different ways of rearranging the 3 variables y, x, and k. Alright, let's try some practice. Which of the following is a like term of j, k, l? See if you can solve this on your own. Alright, C was the right answer since klj is the only one that has one j, one k, and one l, just like jkl. Pretty straightforward, right? Okay, now let's look at an example that uses this concept in an expression. Combine the like terms here. Give it a shot on your own, and then come back and we'll do it together. Okay, so let's start with our very first term, yak. And let's go through the expression and see which of our other terms has the same exact variables. We need to find all the terms that have exactly one y, one a, and one k. For now, we can forget about coefficients and signs. We just care about variables, since we're finding like terms. We see that the next term, aky, is a like term of yak, since it has one y, one a, and one k, just like yak. Great! Our next term is ka. Right away, we see that while this does have an a and k, because it has no y, it is not a like term of yak. Our last term is yka, and this is a like term since it has one y, one k, and one a. Now let's combine all the like terms of yak together. Here we must use the coefficients and signs. So we have 1 minus 1 plus 2, which is 2 yak. We could have written yak as aky, yka, or some other combination, but they all mean the same thing. Looking back at our expression, we see that we only have one term left, and this is not a like term of yak. So if we combine these two together, we see that we have our final answer. This is the simplest form. Great job! Okay, on to our next example. Can we simplify this expression by combining like terms? See if you can do this on your own. Alrighty, first, let's look for the like terms of our first term, 2abc. Like terms will need 1a, 1b, and 1c. Looking through our expression, we see that only 4cba matches these requirements. So, we can add these two together since they are like terms, and this gives us 6abc. Okay, so here's what's left in our expression. Let's find like terms of our next term. Like terms will have 1a, 1b, and 1d. Out of the other two, we see that negative 2 dba is a like term of 3abd. So we can combine these together. This gives us 1abd, which is the same as abd. We have one term left in our expression that has no like terms. So we can combine everything together to get our simplified expression. Awesome work! You did fantastic! At first, it may be hard to find like terms, but it's nothing that can't be solved with some closer observation. Sometimes, it can be hard to find like terms, but with practice, it will only get easier. So, on your own, try grouping these like terms. Comment your answers down below in the comments, and check the description for the answers. You'll do amazing! If you enjoyed this video, please consider subscribing and hitting that like button. Alright, that's all for this video. Keep working hard and keep learning. Thank you for watching.